Okay, so today we have section 3.7 where we're going to evaluate determinants and also be able to apply Cramer's rule with matrices. The determinant of a matrix is a number, and it's associated with square matrix. So again, it can only be like with a 2 by 2 or a 3 by 3. It can't be like a 3 by 2 because it's not a square matrix. It has to have the same number of rows and the same number of columns. And you can write or you can write a determinant of a matrix in two different ways. You can say the determinant of matrix A, whatever that may be, whether it's a 2 by 2 or 3 by 3, which is those are the two dimensions that we're going to work with today. Or we can say that this is the determinant of A. And it kind of looks like, those two bars kind of looks like absolute value, but when it's attached to a matrix, we are talking about the determinant. And it has nothing to do with absolute value. It's just how they write it for this case. So two different ways that we're going to show you how to write a matrix. First off is we're going to find the determinant of a 2 by 2 matrix. And how you find the determinant of a 2 by 2 matrix, let's say we have values of A, B, C, and D. It can be rewritten as, again, like the determinant of A, B, C, and D. And all we're doing is we're taking the product of A and B minus the product of B and C. And whatever that is, that's going to be, whatever that value may be, that's going to be our determinant. With 3 by 3, it's a little bit more complex. So here's how I'm gonna show you. This is the kind of the general formula, but once I show you what you have to do, it isn't really all that bad. So first thing that you have to do when you get the determinant of a 3 by 3 matrix, you have to repeat the first two columns to the right of the determinant. But what I like to do is I just like to write my determinant twice. So here is the determinant written once, and here's the determinant of the matrix written twice. So, and then step 2, it says multiply and add the what is called the upward diagonals. So I'm going to place this in red. So I'm going to go, so here's the upward diagonals. So this is where they get the A times E times I. And then here is the next one where they get B times F times G. And then now we have C times D times H. So that's where they get those numbers. And then we subtract it by the downward diagonal. So I'll show you what that is. So here I have G times E times C. I have H times F times A. And then I have I times D times B. So once you take the products of those values, add those together in the parentheses, subtract them, that's how we get the determinant of a 3 by 3 matrix. Okay? So let's take a look at an example. So here I have, let me get some room here. I have an example of a 2 by 2 matrix and a 3 by 3 matrix. So let's look at example A. So all we have to do here is I'm going to multiply -4 times -5, which is going to give me a positive 20, minus 3 times 2, which is 6. And then I take the difference of those, which will give me 14. So the determinant of this particular matrix is 14. Now when I look at B, again, what I'm going to do is I'm just going to rewrite, it's not equals, I don't know why I wrote equals. So what I'm going to do is I'm just going to repeat this matrix. I'm going to go 6, 5, -2, 1, 3, -3, -4, 2, and 5. And I'm just going to repeat that again. So I got 6, 5, -2, 1, 3, -3, -4, 2, and then 5. So what I'm going to do now is I'm just going to circle all the first products that I'm going to multiply from. Okay, so this is here. So I have 6 times 3 times 5, which that will give me 90, plus 5 times -3 times -4, that'll give me a positive 60, plus -2 times 1 times 2 will give me a -4. So now I'm going to subtract this by these values here. So now I have -4 times 3 times a -2, so that gives me a positive 24, plus 2 times -3 times 6, and that gives me a -36. And then I have 5 times 1 times 5, so that's plus 25. So if I add all these together, for this left parentheses, I get 146 minus, and on the right side of the parentheses, I get 13. So when I take the difference of those, I get 133. So the determinant for this 3 by 3 matrix is 133. Another thing that we can use the determinant for is being able to find the area of a triangle, which vertices are made up of coordinate points on the xy coordinate plane. And here is the general equation for finding the area of a triangle using the determinant of a matrix. So if we recall, our formula when we don't use it is 1/2 base times height. And here it is area equals plus or minus 1/2 the determinant of whatever x1, y1 to the all the matrices in the third column is going to be 1, and it's just being able to apply the points that are given to each specific triangle. Now, as you can see that my 1/2 has a plus or minus attached to it. The reason for that is because sometimes the determinant here is a negative number. And if that does happen, we must use the negative 1/2 to multiply it to. Reason for that is because area is a positive number. Area cannot be a negative number, so that's where that becomes useful. So if the determinant's positive, you use the positive 1/2. If the determinant's negative, you use the negative 1/2. That's the reason why that's there. So for this example, I have they want me to take the appropriate coordinates in miles of a triangular region representing cities and suburbs that are in coordinates 10, 20, -8, 5, and -4, -5, and you want me to find the area of this region. So what I'm going to do is we're just going to find area. So we got A equals plus or minus 1/2 times the determinant of this matrix. So I'm going to write 10, 20, and 1. Then I got -8, 5, and 1. And then the last one's -4, -5, and 1. So what I'm going to do is I need to find the determinant of that matrix. So what I need to repeat these numbers. So I'm going to go 10, 20, 1, negative 8, 5, 1, negative 4, negative 5, 1. And I'm just going to repeat this so I can use my products and add them together. So I'm going to go 10, 20, 1, negative 8, 5, 1, and negative 4, negative 5, 1. So so I'm going to circle this one, and this one. So in my parentheses here, I got 5 times 10 times 1, that gives me 50, plus 20 times 1 times negative 4, which gives me a negative 80. And then I have 1 times negative 8 times negative 5, which gives me 40. And then it's minus these values. Okay. So first one is negative 4 times 5 times 1. That gives me a negative 20. Plus negative 5 times 1 times 10. That's a negative 50. Plus 1 times negative 8 times 20, which gives me a negative 160. So the red parentheses will end up giving me a value of 10 minus the blue ones will give me a value of a negative 230. I take this is a negative, so this becomes a plus, so the value of the determinant for this matrix is 240. So, now that I know that the determinant is 240, and my determinant is a positive number, so that means I can use the positive 1/2 and then multiply it by 240. So I know that the area of this particular triangle in miles is 120 square miles. So it just labels like that. Okay. The next thing we have, and then the last thing we have, is being able to apply what is called Cramer's Rule. Cramer's Rule is being able to take systems of linear equations like we did earlier in Chapter 3 and be able to apply them in a matrix sense. So to my left here I have the linear system ax plus by equals e, and then the second equation is cx plus dy equals f. Both of those are written in standard form. That's important when you're writing out the linear system, and what it does is it helps us be able to determine what we're going to write for the matrix. So here is the linear system, and this is its matrix counterpart. All you're doing is placing the coefficients with the variables. So you have the matrix A, B, C, D in this case. And the reason why this is important, this is just another way of us being able to solve linear systems, but this we were able to do it with substitution elimination through algebra. We were able to do it through graphing, and now we are able to do it through using the matrix and being able to solve it with the determinant. So granted, if the determinant does not equal 0, then the system has exactly one solution. The solution can be given by, and if you look here, this is to show how we can solve for x, and what it is, it's the determinant of EBFD, where E and F were our constants in our systems of linear equations, and then to solve for y, we put our constants located at where the y coefficients were located. So when we're solving using Cramer's rule, I'll get some room here. What I have here is 6x minus 2y equals negative 16, and I got 3x plus 5y equals 16. So first thing I have to do is I need to write this as a coefficient matrix. So when I write this as a coefficient matrix using the A, B, C, D format, my matrix would become 6, negative 2, negative 3, and 5. So what I need to do first is I need to find the determinant for this particular matrix. So the determinant of this would be, we'll just call it matrix A, will equal 30, which is right here, minus positive 6. So the determinant for this matrix A will end up equaling 24. So what we need to do is we need to solve for x, or find what x equals. And x will equal the determinant of, by the matrix, by placing the constant coefficients where my x values were. So I'm going to have negative 16 and 16 here, and then we'll still have the negative 2 and 5 from the y values. And then this gets divided by the determinant of my matrix A, which happens to be 24. So what I need to do is I need to find the determinant of my numerator in this case. So if I use this value here, it's negative 16 times 5 will give me a negative 80, minus 16 times a negative 2, which gives me negative 32. This goes plus plus, divide that by 24. And then negative 80 plus 32 gives me a negative 48, divided by 24. And then my x comes out to equal negative 2. If I wanted to find my y, again, I'm going to take the determinant of my matrix with my constants on the y coefficient column. So I'm going to rewrite this as 6 and negative 3, because those are my x. And then my constants will be negative 16 and 16 here, all divided by the determinant of A, which was 24. So I need to find the determinant of my numerator. So I look at this value here, so that becomes 16 times 6, which gives me 96, minus 3 times, or negative 3 times negative 16, which gives me a positive 48, all divided by 24, equals, this gives me 48 is divided by 24, and 48 divided by 24 gives me 2. So x equals negative 2, y equals 2. And we can prove to see if those hold true by plugging them back into both of those systems to see if it's a true statement. If we use negative 2 times negative 6 would give me a negative 12. And then if I had y is 2, that gives me 4. So negative 12 minus 4 equals a negative 16. That holds true. If I use negative 2 in for x, that gives me positive 6 plus 10. So 6 plus 10 is 16. That is also true. So that would end up making those this value a true statement by validating what we did through using Cramer's rule. If we have a 3 by 3 matrix where we're going to solve systems of 3 different equations, we can again rewrite this as the coefficients of matrix A, B, C, D, E, F, G, H, I. And then what if we were given a constants of what is J, K, L? Okay, so it's exactly the same thing as it was as a 2 by 2 matrix. Now we're just having a bigger matrix with, so we're going to solve for 3 values of x, y, and z rather than just x and y. Same rules apply if we're trying to solve for x. Our constant values will go under the x column, and then we'll divide this matrix, or the determinant of this matrix, by the determinant of our constants of coefficients, or just our coefficient matrix, I'm sorry. Our y's, our constants show up as y, and z, our constant shows up in the z column. So that's what makes the difference between solving for x, y, and z. So when I have this example here, they want me to solve for the linear equation using Cramer's rule. So the first thing you have to do is you need to find the matrix, or you need to find the determinant of the matrix of our coefficients. So the matrix looks like this. It would be written as 3, -1, 1, -1, 2, -3, and then 1, 1, 1. So that would be our coefficient matrix for this particular example. So if I was trying to find the determinant of this, we'll just call it the determinant A. We'll say that this would equal 3, -1, 1, -1, 2, -3, and 1, 1, 1. I'm just going to rewrite this. So I'm going to go 3, -1, 1, -1, 2, -3, and 1, 1, 1. So when I have these values here, I'm going to multiply these and then add the products together. So here I have 3 times 2 times 1, which gives me 6, plus -1 times -3 times 1, that gives me +3, plus 1 times -1 times -1 by 1, that gives me -1, minus these values here. So when I put them in parentheses, I get 1 times 2 times 1, which gives me 2, plus 1 times -3 times 3, which gives me -9, plus 1 times -1 times -1, which gives me 1. So the first parentheses would be 8, so it's minus a -6, and so this is plus plus, which equals 14. So my determinant of A is 14. So let's say I'm going to try to solve for x here, which means that I need to find the determinant of the matrix with my constants in my x column. So that's going to give me 25, -17, and 21, which are my constants, and then I just rewrite the rest of them. So it becomes -1, 1, 2, -3, and then 1 and 1. And then all of this gets divided by 14. So what I'm going to do is I'm just going to repeat this. So I'm going to put 25, -1, 1, -17, 2, -3, 21, 1, and 1. So I need to find my determinant of my top values. So it becomes this value here, product of these ones here, and then product of this one's here. So this becomes 25 times 2 times 1, which gives me 50, plus, which would be what, -1 times -3 times 21, which gives me a positive 63, plus 1 times -17 times 1, which gives me just a -17. It would be minus these values. So I get so it becomes what, 21 times 2 times 1. So that's what, 42. Then I have 1 times negative 3 times 25, which gives me plus negative 75. And then it's plus 1 times negative 17 times negative 1, which gives me a positive 17. So if I take these together, I'm going to get 96 minus a negative 16, all divided by 14. So this goes plus plus. So it becomes equals 112 divided by 14. So my x here will equal 8. So that's finding x. To find y, we're going to put our constant values in the columns of the y value. So that means that we're going to find the determinant of this matrix, which would be 3, negative 1, and 1. Now here's where the constants come in again. So we got 25, negative 17, and 21. And then the last one will just be the coefficients of z. So we have 1, negative 3, and 1. So I'm just going to repeat these values and find the determinant of our numerator. So I got 3, 25, and 1, negative 1, negative 17, negative 3, 1, 21, and 1. All of which is divided by 14, which is our determinant of our coefficient matrix. So if I take these values here and I go, let's circle them for you. So it becomes 3 times negative 17 times 1, which gives me negative 51, plus 25 times negative 3 times 1 gives me a negative 75, plus 1 times negative 1 times 21, which gives me 1 negative 21, minus these values here. You gotta be careful when you make these circles so you don't mess them up, which can happen, so please be careful. So now I have 1 times negative 17 times 1, which gives me a negative 17, plus 21 times negative 3 times 3, which gives me a negative 189. And then I have 1 times negative 1 times 25, which gives me a plus negative 25. So this is, the first parentheses will give me, what, negative 147 minus a negative 231. So this goes plus plus. So this ends up equaling the 84. And then I divide that by 14, which then equals, so my y then will equal 6. The last one is z. So again, we're going to do the exact same things, but now we're going to put our constant values in the z column. So rewrite this as 3, negative 1, and 1 becomes negative 1, 2, and 1. And then I just write this as 25, negative 17, and 21, all of which is divided by 14. So I'm just going to rewrite the top one so I can find the determinant of our numerator. So I got 3, negative 1, and 25, negative 1, 2, and negative 17, 1, 1, and 21. So, again, circle our values here. So it becomes these products. So it's 6, or well, 3 times 2 is 6, times 21 is 126, plus negative 1 times negative 17 times 1 gives me just positive 17, and 25 times negative 1 times 1 is negative 25, minus the values here. So now I'm going to have 1 times 2 times 25, which gives me 50, plus 1 times negative 17 times 3, which gets me, what, negative 51, plus 21 times negative 1 times negative 1, which gives me 21. So my first parentheses ends up giving me 118 minus 20, all of which is divided by 14. So this equals, what, 98 divided by 14. And so my z ends up equaling 7. So my x is 8, my y is 6, and my z is 7. And then we can prove that's hold true by plugging them back into our original equations to see if they come up with true statements. And that is being able to evaluate determinants and applying Cramer's rule. So I hope this helps. Until next time.